STEM teachers use the professional learning community, or PLC, to plan learning management, in which teaching is organized in a team teaching by teachers who specialize in various fields and share the results after learning management. And the suggestions will be used in the development of teacher learning management next time. TUPP STEM team has managed STEM education with project-based learning in the subject of research and solving problems by scientific methods for students in Matayom 4 or Grade 10 gifted program on the topic of wastewater treatment. Wastewater is a crucial environmental problem for schools because small substance from the canteen contaminating the wastewater pipe and releasing it into the pond cause wastewater inside and neighboring areas. In the learning management, the students were divided into 6 groups of 4 to 6 people in each group to create a prototype of wastewater treatment system by integrating knowledge from science, technology, engineering, and mathematics. In addition, students must consider the correct selection of materials and equipment and calculate the price to evaluate the value of the prototype. In the STEM learning management process of Ttream Udom Suksa Patanakan Suvarnabhumi School, it is divided into 3 sessions, 8 activities. The total learning time is 34 hours. Details are as follows. Session 1. STEM pre-activity. Activity 1. Transporting eggs using parachute. 2 hours. The teacher gives an example of a situation. Then let the students divide into group of 4 to 6 people so that students can integrate knowledge in different fields to use in solving problems. Activity 2. Context introduction. 2 hours. Each group of students surveyed to determine the cause of a school's wastewater. It started by observing the environment within the school, study the flow path of water. Wastewater samples were collected from the pond behind the school and canteen, record the physical properties of wastewater, such as color, odor, turbidity, pollutants, etc. Then each group of students can present the information they have studied. Activity 3. Evaluate the level of the problem. 4 hours. Each group of students search for parameters to measure the physical and chemical properties of water. Activity 4. Laboratory equipment training. 6 hours. Teachers teach basic practical techniques used in the parameter determination process for measuring physical and chemical properties of water, including fat, oil, and grease, or FOG, pH, dissolved oxygen, or DO, total soluble solid, or TSS, total dissolved solid, or TDS, and how to use a turbidity sensor. The teachers, who are experts in each field, work together to design learning management. Section 2. Finding solutions. Activity 5. Build up the background knowledge. 4 hours. Teachers design learning activities to enable students to acquire research process skills by jigsaw learning. Each station will provide knowledge about wastewater treatment processes in different ways. Then, let members within the group separate to study. Then the students gather together and exchange methods for treating wastewater in order to apply the knowledge in the design of the wastewater treatment system in next step. Activity 6. Proposal preparation. 6 hours. The students in the group work together to design a wastewater treatment system prototype, along with explaining how to treat wastewater in each section. Then, the teacher teaches how to design using GeoGebra and Blender to help students design a wastewater treatment system in 3D. Section 3. Presentation and feedback. Every group of students presented a prototype of a wastewater treatment system designed using GeoGebra and Blender programs. Wastewater treatment method in each section along with identifying materials used in modeling wastewater treatment system, with STEM teachers giving advice. Then, have the student modify the wastewater treatment prototype again. Then presented the second prototype of the wastewater treatment system. Activity 8. Application or testing the solutions. 8 hours. Every group of students create the wastewater treatment system model as they design. Then, test the flow of water in the wastewater treatment system, record the test results, and identify any problems with STEM teachers giving advice. Students revised the first wastewater treatment prototype, then took the new prototype for a second test, and recorded the test results, and identified any problems. Each group of students edited and tested the wastewater treatment system until a prototype could be used to actually treat wastewater with STEM teachers giving advice. Each group of students tasted a prototype of a wastewater treatment system in the school's wastewater. The students can choose wastewater sources according to their interest, and they measure and record the water parameters first and after treatment, with STEM teachers giving advice. The students presented their results using the wastewater treatment prototype and exchanged knowledge in the form of a gallery wall.